The James Webb Space Telescope is doing something truly extraordinary, something fundamentally disruptive. It's not just adding footnotes, it's tearing pages out of the astronomical playbook. All of a sudden, we are confronting the staggering reality that our most cherished understandings, meticulously built over generations, might need a complete overhaul. This cosmic powerhouse is forcing us to reconsider the very foundations of cosmic history, potentially demanding a rewrite of every textbook detailing the universe's fiery birth. And when this technological titan, the James Webb Space Telescope, pivoted its phenomenally sensitive gaze towards the distant, enigmatic world of Pluto, the astronomical community braced itself. But no one, absolutely no one, was truly prepared for the sheer earth-shattering impact of what it would unveil. The images that streamed back weren't merely incremental improvements. They were nothing short of revolutionary, a quantum leap in our perception of this frozen sentinel at the solar system's edge. For decades upon decades, Pluto existed as the ultimate cosmic tease, a distant, shadowy enigma perpetually cloaked in icy darkness and profound mystery. Even the breathtaking historic flyby, executed by NASA's New Horizons mission in 2015, which delivered our first intimate portraits, left us paradoxically with more burning questions than definitive answers. The fleeting encounter, while magnificent, was just that, fleeting. It provided snapshots, glimpses into a complex world we yearned to understand over time. But now, armed with Webb's staggering infrared might and unprecedented razor-sharp resolution, we are witnessing Pluto with a clarity that borders on the surreal, a level of detail previously confined to the realm of science fiction. And the implications radiating from this torrent of pristine new data, they are utterly staggering, potentially rewriting the narrative of our solar system's frozen frontier. Pluto, that celestial underdog once hailed as the ninth planet before its controversial reclassification, continues to exert an irresistible gravitational pull on the imaginations of scientists and space enthusiasts alike. Residing deep within the Kuiper Belt, a vast icy graveyard of primordial remnants over 3.66 billion miles from the warmth of our sun, this dwarf planet has perpetually posed a monumental challenge for detailed scrutiny. Traditional telescopes, even the venerable and legendary Hubble Space Telescope, strained to their absolute limits, could only offer frustratingly blurry, indistinct glimpses of its surface features, tantalizing hints obscured by the immense gulf of space. The James Webb Space Telescope, however, has fundamentally, irrevocably changed the game. Its colossal 6.5-meter primary mirror, coated in a whisper-thin layer of gold for optimal infrared reflection, combined with its privileged position perched beyond the distorting veil of Earth's atmosphere, allows Webb to capture the faintest whispers of light from the most distant objects with a precision that defies belief. When it meticulously focused its unparalleled gaze upon Pluto, the resulting image wasn't just a picture, it was a revelation, laying bare textures, geological formations, and intricate atmospheric details in ways never before dreamt possible, peeling back layers of mystery we thought might remain forever hidden. What elevates this achievement into the stratosphere of the incredible, the truly mind-blowing, is the fundamental way Webb perceives the cosmos. Unlike telescopes confined to the narrow band of visible light that our eyes can see, Webb primarily observes the universe through the revealing lens of infrared wavelengths. This is the critical game changer. It means Webb can detect the faint heat signatures of celestial objects, the subtle telling variations in temperature and chemical composition that optical telescopes are utterly blind to. For Pluto, a world locked in a deep freeze, this infrared vision is nothing short of transformative magic. It allows scientists to pierce through its thin, ethereal atmosphere like never before, directly sensing the frigid surface ices, nitrogen, methane, carbon monoxide, and detecting the faintest thermal whispers that might betray potential geological activity simmering beneath the icy crust. The groundbreaking new image, jointly released by NASA and the European Space Agency, isn't just a photograph. It's a data-rich tapestry revealing intricate jaw-dropping details of Pluto's sprawling nitrogen ice plains, its surprisingly rugged mountainous regions sculpted by unknown forces, and even tantalizing dynamic shifts potentially linked to seasonal changes unfolding within its tenuous atmosphere. It's a dynamic portrait of a world we thought was static and dead. One of the most stunning, heart-stopping revelations screaming from Webb's profound new image is the sheer, unprecedented detail captured of Sputnik Planitia, that iconic, heart-shaped region dominating Pluto's surface. This vast, strangely smooth plain, composed predominantly of volatile nitrogen ice, was first dramatically unveiled in all its glory by New Horizons in 2015, capturing the world's imagination. But Webb's extraordinary infrared sensitivity penetrates far deeper, revealing intricate depth and complex texture that were utterly invisible before, hidden beneath the surface glare. Subtle, yet significant variations in brightness dancing across the expanse of Sputnik Planitia aren't just random patterns. They are screaming clues, potentially signaling ongoing, active surface processes. This could be the telltale signature of nitrogen ice sublimating directly into gas under feeble sunlight. Or, conversely, frost depositing back onto the surface as temperatures plummet. This isn't the behavior of a geologically dead world frozen in time. It points shockingly towards a Pluto that may still be geologically active, harboring internal heat or dynamic processes that defy expectations for a body so small and so profoundly frigid, existing in the sun's deep freeze. This single finding shatters long-held assumptions. Webb's revolutionary data is also empowering researchers to dissect Pluto's wisp-thin atmosphere in ways that were previously pure fantasy, impossible with any other instrument. Composed primarily of nitrogen, with mere traces of methane and carbon monoxide adding complexity, Pluto's atmosphere is vanishingly tenuous and bitterly cold. Yet, through Webb's infrared eyes, subtle critical shifts in temperature gradients and minute variations in chemical composition become starkly, undeniably apparent. Scientists are now, for the very first time, able to meticulously trace intricate changes in atmospheric pressure and thermal profiles over time. This isn't just data. It's a Rosetta Stone offering profound clues about Pluto's epic seasonal cycles, which unfold with glacial slowness over its mammoth 248-year orbit around the Sun. Understanding how this ethereal envelope breathes and changes over such cosmic timescales is key to unlocking the dwarf planet's climatic history and present state. The implications are vast, but the revelations don't stop at Pluto's lonely horizon. Webb's phenomenally powerful instruments have also pierced the darkness to capture stunningly new details about its entourage of 5 known moons, with Charon, the largest and closest, receiving particularly intense scrutiny. Charon has perpetually intrigued scientists, not just due to its substantial size, half the diameter of Pluto itself, making it the solar system's largest moon relative to its primary, but also because of its synchronous orbit, forever locking the same enigmatic face towards its partner. Webb's cutting-edge imaging has now ripped the veil away, revealing fresh, electrifying insights into Charon's surface composition. The data hints provocatively at the presence of frozen ammonia, complex organic hydrocarbons, the very building blocks of life as we know it, and intriguing changes in its crustal structure. These subtle alterations could be the smoking gun, suggesting a far more dynamic, tumultuous geological history than anyone ever dared to attribute to this distant, frozen companion. It paints a picture of a moon that might have been far more active and complex in its past, perhaps even harboring secrets beneath its icy shell. The story is getting infinitely more complex. Beyond the captivating dance of Pluto and Charon, the telescope has also turned its formidable gaze upon Pluto's smaller, enigmatic moons, Styx, Nix, Kerberos, and Hydra. These tiny, irregularly shaped celestial bodies, often resembling captured asteroids more than born and bred moons, have consistently eluded detailed study due to their extreme distance, diminutive size, and faintness. But now, armed with Webb's unparalleled light-gathering power and resolution, scientists can achieve feats once thought impossible. They can now refine the precise wobbling orbits of these celestial gnats, make groundbreaking estimates of their surface compositions based on their infrared signatures, and piece together far more robust theories about their chaotic origins. Whether they coalesced from debris after a cataclysmic impact on Pluto or were captured from the swirling population of the Kuiper Belt. Every single new data point, every refined measurement, contributes significantly to weaving a deeper, more coherent understanding of the entire Pluto system and the complex, dynamic processes silently at play in the solar system's desolate, frozen backyard. It's a system coming alive with data. What's even more fascinating, more intellectually electrifying, is how Webb's breathtakingly clear image violently reopens the long simmering, often heated debate about Pluto's very planetary status. Although the International Astronomical Union, IAU, controversially reclassified Pluto as a dwarf planet back in 2006, primarily based on its size and its failure to clear its neighborhood, the stunning new data pouring in from Webb throws a massive wrench into the tidy categorization. Webb showcases Pluto's shocking complexity and apparent ongoing geological activity. Features like layered terrains, shifting ices, and a dynamic atmosphere, directly challenging the core assumptions that led to its seismic demotion. Many prominent astronomers are now forcefully arguing, with fresh, undeniable evidence, that Pluto exhibits characteristics far more commonly, perhaps even quintessentially, associated with full-fledged planets. This includes potentially differentiated internal layers, a core, mantle, crust, a dynamic albeit thin atmosphere exhibiting seasonal changes, complex geology sculpting its surface even today, and the persistent, tantalizing possibility of a hidden subsurface ocean lurking beneath its icy carapace. Webb isn't just showing us Pluto, it's forcing us to fundamentally reconsider what a planet truly means. The debate is back, and it's fiercer than ever. This paradigm-shifting high-resolution observation also brutally underscores the screaming importance of continuing our relentless exploration of the Kuiper Belt. Pluto is merely the brightest, most famous denizen of this vast, unexplored realm. Just one among thousands of icy bodies silently orbiting the Sun beyond the orbit of Neptune, frozen relics from the solar system's violent birth. With Webb's unprecedented clarity and sensitivity now available, researchers can target similar, elusive objects with pinpoint accuracy and revolutionary detail. This includes other intriguing dwarf planets like Eris, slightly more massive than Pluto, Makemake, and Haumea, as well as countless mysterious unnamed objects still waiting silently in the dark to be discovered and understood. Each new image Webb captures, each new spectrum it analyzes, adds a vital, irreplaceable piece to the grand, complex puzzle of how our solar system formed, evolved, and settled into its current configuration over billions of years. We are reading the frozen history of our own cosmic neighborhood. The Kuiper Belt is no longer a frontier. It's an open book, waiting for Webb to read it. The James Webb Space Telescope represents so much more than just a new set of eyes gazing skyward. It embodies a colossal, generational leap in how we observe, perceive, and ultimately comprehend the universe. Unlike its revered predecessor Hubble, which focused primarily on optical and ultraviolet wavelengths, Webb's specialized infrared capabilities are its superpower. It allows this cosmic observatory to pierce effortlessly through obscuring veils of interstellar dust, detect vanishingly faint heat sources radiating from the coldest objects, and reveal celestial bodies too frigid, too distant, or too shrouded to be seen by any other means. This capability is utterly invaluable, absolutely mission-critical when studying distant frozen worlds like Pluto, which emit only a pathetic trickle of visible light but blaze forth with comparatively rich information in the infrared spectrum. Webb sees the heat where others see only darkness. It transforms the invisible into the visible. Webb's stunning success in imaging Pluto with such exquisite detail also dramatically pushes the boundaries of what we believed space telescopes could realistically achieve. Its ability to precisely track and maintain a laser-like focus on a tiny, incredibly distant, and fast-moving target like Pluto showcases an extraordinary, almost unbelievable level of engineering precision and computational sophistication. Capturing such a flawlessly detailed image demanded Webb's sophisticated fine guidance sensors to operate with near-perfect accuracy, continuously compensating not only for the spacecraft's own subtle motions, but also for Pluto's achingly slow drift against the seemingly fixed backdrop of distant stars. This astonishing level of precision isn't just impressive. It highlights Webb's breathtaking versatility in the starkest possible terms. Not only can it peer back across mind-bending gulfs of space and time, witnessing the formation of the very first galaxies bathing in the light of infant stars billions of years ago, but it can also simultaneously deliver crisp, profoundly insightful data from our own solar system's icy backyard. The telescope's unique, unparalleled strength lies precisely in this effortless ability to shift from exploring the most ancient, red-shifted galaxies at the edge of time to targeting dynamic, icy worlds orbiting our own sun, all with equal prowess. This opens up dizzying, thrilling possibilities for future studies of other enigmatic distant objects, like Neptune's bizarre, retrograde orbiting moon Triton, suspected to be a captured Kuiper Belt object itself, or Eris, another colossal denizen of the deep Kuiper Belt. With each groundbreaking new observation, Webb relentlessly expands our understanding of the solar system's farthest, coldest reaches, an area still vastly unexplored, shrouded in mystery, and positively overflowing with the electrifying potential for paradigm-shattering discoveries. The frontier is calling, and Webb is answering. As scientists across the globe continue to feverishly analyze the deluge of data Webb has provided on Pluto, new, even more profound questions are rapidly crystallizing, pushing the boundaries of our curiosity. Is there truly a hidden, global subsurface ocean churning with salty water beneath Pluto's thick, icy shell, potentially kept liquid by residual heat and antifreeze compounds, mirroring what we suspect exists on moons like Europa and Enceladus? What mysterious unseen forces could possibly power the apparent geological activity, the shifting ices, the potential cryovolcanism, on a world so desperately distant and locked in such profound, unrelenting cold? Are there cryovolcanoes, silent and frigid, actively reshaping Pluto's alien landscape, periodically erupting not with molten rock, but with slurries of water ice, ammonia, nitrogen, or methane, releasing volatile compounds from the dwarf planet's hidden interior depths? Webb, powerful as it is, cannot answer all of these profound questions alone. However, its revolutionary data helps frame them with infinitely greater clarity, offering vital, unambiguous clues and hard evidence that will directly guide the design and targets of the next generation of robotic missions and fuel the development of bold new theoretical models. Webb is lighting the path forward. Another electrifying, intellectually rich outcome emerging from Webb's exquisitely detailed imaging is the burgeoning opportunity for advanced comparative planetology on a scale never before possible. By meticulously studying Pluto alongside other enigmatic icy worlds, like Saturn's haze-shrouded, hydrocarbon lake-dotted Titan, Neptune's captured and geysering Triton, or even Jupiter's potentially ocean-harboring Europa, scientists can begin to identify universal patterns and critical differences that illuminate broader cosmic processes. For instance, how does Pluto's complex nitrogen cycle, involving sublimation, deposition, and atmospheric transport, compare to the suspected similar cycle operating on Triton? Are the complex organic compounds spectroscopically detected on Pluto's surface chemically akin to the tholins raining down on Titan? Is there compelling evidence etched into Pluto's ancient battered crust that points to violent, chaotic collisions during the solar system's tumultuous early history within the Kuiper Belt? These cross-comparisons aren't just academic exercises. They are essential keys that unlock a deeper, more unified understanding of planetary evolution, not only within our own solar system, but also providing crucial context for interpreting the bewildering variety of exoplanet systems Webb is uniquely designed to probe. We are building a universal science of icy worlds. Yet, Perhaps the most profound, deeply resonant impact of this revolutionary new image lies not solely within the cold, hard scientific data it provides, but in what it represents for humanity's insatiable spirit and collective ambition. Cast your mind back just a few short decades ago. Pluto was little more than a blurry, frustratingly featureless speck of light, even in the very best telescopes Earth could muster. It was the ultimate symbol of cosmic mystery, distant, unknowable, a ghostly pixel in the void. Now, thanks to the almost superhuman capabilities of the James Webb Space Telescope, a monument to human ingenuity, we can see. We can see its vast frozen nitrogen plains shimmering under the weak sun, its rugged water ice mountains thrusting skyward, its delicate hazy atmosphere clinging to the horizon. We can trace intricate, almost artistic patterns within its iconic frozen heart, Sputnik Planitia. We can glimpse the slow, silent, gravitational ballet of its moons. Charon, Styx, Nix, Kerberos, Hydra, dancing in the perpetual twilight. We can finally, truly begin to tell its story. This isn't merely incremental progress in the field of planetary science. It stands as a powerful, awe-inspiring testament to the relentless power of human curiosity, our boundless imagination, and our sheer, dogged determination to reach beyond the known. Every single breakthrough image Webb beams back, every precious dataset it delivers, is the direct result of decades of unwavering work, sacrifice, and collaboration by tens of thousands of scientists, engineers, technicians, astronomers, and dreamers across the globe. It represents humanity collectively reaching beyond what seemed physically possible, pushing the very limits of technology and knowledge. Webb's stunningly clear image of Pluto serves as a visceral, humbling reminder that the universe is an infinite wellspring of wonder, always poised to reveal something astonishingly new, something profoundly unexpected. If we possess both the visionary tools to look and the unbreakable will to seek, it reaffirms our place as explorers. So, as we stand awestruck, gazing upon this beautifully intricate, impossibly clear picture of a world 3.66 billion miles away, we are powerfully reminded of the incredible, generation-spanning journey. From Clyde Tombaugh's meticulous discovery of that tiny, wandering dot in 1930, through the heart-stopping flyby of New Horizons that brought it into shocking focus, and now to this breathtaking, transformative next chapter unveiled by Webb. It's an epic saga of exploration, a chronicle of relentless innovation, and the unending noble quest to understand our place within the vast, magnificent cosmos. And this story, this magnificent adventure of discovery, it is gloriously, undeniably far from over. With each unprecedented observation, Webb is doing far more than simply capturing ancient light traversing the universe. It is brilliantly illuminating the path forward, revealing the next questions, the next frontiers, beckoning us ever onward. The James Webb Space Telescope's revolutionary image of Pluto unequivocally marks the dawn of a thrilling new era in our comprehension of the outer solar system. It's not merely a static picture, it's a profound revelation, a visceral glimpse into a world once thought condemned to eternal obscurity by its impossible distance, now brought into stunning, almost intimate focus. And it stands as a solemn, inspiring promise. As long as humanity retains the courage to keep reaching, to keep building, to keep questioning, the universe in its infinite mystery will keep answering. The conversation has just begun, and Pluto is speaking volumes. The cosmos awaits.